Welcome to Fast Math Solutions on Math with EJD. Today we have a very interesting question. We want to show that the determinant of this matrix M, y sine beta cos beta minus sine beta minus y1 cos beta 1y is independent of beta. That means that by the time you find the determinant, beta will not be part of the result. That's what that is simply asking us to do. So what do we do? Just do your normal determinants. You know how to do determinants normally. Normally you assign plus, minus, plus, and then you take y and cross out. But that's one method. But here I'm going to use the rule of Sarrus, or what you can call the Sarrus rule. And of course, the easiest way to make that come out is to write all the three rows. Row 1, you have it here. Row 2, you have it here. Row 3, you have it here. Then after doing that, you repeat row 1 and row 2 again, So row 1 is repeated. So you have what you have here comes here. This one also comes here. So with this, it's easy to now do the Sarrus rule. And what does the Sarrus rule tell us? Now that you have written this way, then you can now do the crossing out. For instance, for the positives now, you cross this. So that goes that way. So for positive, that's 1. The second thing is this. And the third one is this. That's for the positives now. So all this will go for the positives. Or let me use another color entirely. Let me do green. Okay, let me do green. All right. So for the positives, we have 1, 2, and 3. Those will be the positives. For the negatives, let's use red. So for the negatives, of course, you have this, and this. And according to Sarrus, what happens? So these are the negatives now. So for the positives, it means you have plus y times minus y times y. That's minus y cubed in brackets. Then the next one, the next positive, that's positive here. Minus sine beta times 1 times cos beta. You have minus sine beta cos beta right here. And the third positive is this cos beta times sine beta times 1. That is sine beta cos beta. And for the negatives, let's talk about the negatives. So for the negatives now, the first one you have is cos beta times minus y times cos beta. That is why you have negative outside, because it's part of the negatives. But then when you multiply that out, you have minus y cos squared beta, because cos beta times cos beta is cos squared beta. And then the next negative is y times 1 times 1. That's the negative, and then y, which you get by multiplying y times 1 times 1. And then lastly, the third negative is this minus sine beta, and y. So when you multiply minus sine beta, y, you have minus y sine squared beta. So now that you have done all that, that is basically the Sarrus rule. All you just need to do next is to tidy things up. And to tidy things up, you basically have plus times minus is minus. That's why you have minus y cubed here. And then the next one, you have plus times minus sine beta cos beta. That's minus sine beta cos beta. Plus times sine beta cos beta, you have sine beta cos beta. Minus times minus plus y cos squared beta. Then minus y. Minus times minus is plus y sine squared beta. Okay, so you tidy things up further. And what do you have? You have minus y cube here. So of course, minus sine beta cos beta will cancel sine beta cos beta. So that is gone. So you have y cube, that's down here. Then minus y is out here. Then you have y cos squared beta plus y sine squared beta. They have y in common, so you can put y outside and factorize. So you have cos squared beta plus sine squared beta. In trigonometry, sine squared anything plus cos squared that thing is 1. So for instance, sine squared Emmanuel plus cos squared Emmanuel is 1. Cos squared father plus sine squared father is 1, So this is 1. So cos squared math plus sine squared math is 1. So this whole thing is 1. So we have minus y cubed minus y plus y into cos squared beta plus sine squared beta is 1. So we tidy that up again. And then, already you have minus y cubed minus y plus y times 1, that's y. So here you have minus y cubed plus y minus y. So minus y plus y cancels out, and you have minus y cubed. So you see, though in the matrix, there's beta, but in the determinant, beta is not there. And that that shows that the determinant is independent of beta. So that's all we are required to do in this case. So see you in the next video.